All right, this is 8.3. We are going to talk about zero and negative exponents now. So our little box at the top is going to help us keep track of these different rules. And so the first one is when we have a to the 0 power. So you should have already done the exploration and discovered that a to the 0 power is 1. A can't be 0. So any number besides 0 to the power of 0 is 1. So 5 to the 0 power is 1, 1,000,000 to the 0 power is 1, 245.376 to the 0 power is 1. Now, any number that has a negative exponent, any base that has a negative exponent, can also be written under a fraction bar, and then you lose the negative sign on the exponent. And you should have discovered that in your exploration as well. So 2 to the negative 1 power becomes 1 over 2 to the first power. And we don't really need to write 2 to the first power, so it's just 1/2. So 1/2 is the same as 2 to the negative 1 power. Likewise, if I have a base with a positive exponent, I could write it under the fraction bar and change the sign of the exponent. So 2 to the first power could be written 1 over 2 to the negative 1 power. Okay, so we're going to use what we just learned there to do a couple examples. So example 1, letter A, is 2 to the negative 3 power. So we would write that as 1 over 2 to the third, and then we're actually going to work it out. 2 times 2 times 2 is 8. So that's 1 over 8. So we use the definition of negative exponents to help us solve that one. All right, any number to the power of 0 is 1. That's the definition of a 0 exponent. One-fourth to the negative third power. So the first thing I'm going to do is I'm going to rewrite this as 1 over 1/4 to the third power. And then I'm going to do 1/4 to the third power, which is 1/4 times 1/4 times 1/4, which is 1 over 64. But it's on the bottom still. So it's 1 over 64. So back up here, what did we do? We did the definition of negative exponents. Okay, but I can't leave it like this, a fraction and a fraction. So I have in my numerator a 1, and in my denominator is 1 over 64. So that's like 1 divided by 1 over 64. And what's the rules of division? Flip the second guy and multiply. So really, that just turns out to be 64. Okay? Another way we could have done this one is over here. We're going to do letter C right here. So 1 over 4 to the negative 3 power. So I'm going to actually rewrite this as 1 to the negative 3 power over 4 to the negative 3 power. And I can do that because there wasn't adding or subtracting also in the problem. It was just a division problem. So now I'm going to use my rule of negative exponents, and I'm going to flip where these are at and lose the negative sign. So this becomes a 4 on top raised to the third power. It lost its negative because I moved it to the other half of the fraction. And then this one is 1 to the negative 3, so it's going to move down and be 1 to the 3. Okay, you can have parentheses, or you don't have to have them because there's not a negative sign there. 4 times 4 times 4 is 64, and 1 times 1 times 1 is 1, and I don't even need to put it over 1. So it's the same answer as I got over here, 64. So you can decide which way is easier for you. Most kids probably think this is easier. It's your choice. Okay, 0 to the negative 7 power is undefined. Remember up here, it wouldn't work if the base was 0. So this is actually undefined. Okay, So a to the negative n power is defined only for a non-zero number a. Okay, so what I want you to do right now is I want you to pause the video and I want you to fill in as many of these as you can from memory. So what you're doing is you're writing the rule of basically what would happen here and then naming the property. So I'll do the first one. A to the m times a to the n, they have the same base, so we add the exponents. And that is the product of powers property. Product of powers. Okay, so go ahead and pause the video and fill in the rest. Okay, so you may need to pause again here to kind of get enough time to go through and check your work. All of these were from 8.1 and 8.2, and we were just reviewing them because we're going to be using them here in a second to help us evaluate all of these other examples. Okay, so example 2 is negative 5 to the 4th power times negative 5 raised to the negative 4 power. So this would be product of powers, right? Same base, negative 5. So we keep that base, and what do we do to the exponents? We add them. So that makes it, get my parentheses around there, that makes it negative 5 to the 0 power. This was what we did there. We added the exponents. Anything to the 0 power is 1. That's definition of a 0 exponent. You won't need to name these properties or these definitions on any kind of summative or formative test. They're just to help you keep track of why we're doing things right now. Okay, the next example is positive 5 raised to the negative 2 power, and then again raised to the negative 2 power. So this is 5, and then it's power of a power. This is power of a power property, so I'm going to multiply the exponents. I don't need the parentheses around the 5 because the 5 itself is not negative, but you can have it there if you'd like. So a negative 2 times a negative 2 is actually a positive 4. So we multiplied the exponents there. And then 5 to the 4th power is 5 times 5 times 5 times 5, which is 625. The next one is 1 over 4 to the negative 2nd power. So we're going to use the definition of negative exponents to help us here, because we don't like that negative on the bottom of the fraction. So we're going to move it to the top and lose the negative. We don't even need it over 1. I just put it there to show you we're flipping what's happening here. It's going up to the top, and since there was nothing down there now, I hold its place with a 1. 4 squared is 16. I don't need the 1. Okay, the last one. 3 squared is on top. 3 to the negative 1 is on bottom. So here's the deal. What we need to do is we need to use the quotient of powers property, because they're the same base and it's division. Quotient of powers property. So that means numbers that have the same base, I can do what to their exponents? Subtract. So this becomes 2 minus negative 1, because the exponent on bottom was negative 1. And what happens to minus a negative? It becomes plus a positive. So this is actually 3 to the 3rd. So summarizing what I did up here, I actually, to get up there, I subtracted the exponents. So subtract exponents. And then 3 to the 3rd is 3 times 3 times 3, which is 27. Okay? Now, if subtracting was throwing you off, what you could have done in this problem is you could have done, it was 3 squared over 3 to the negative 1. You could have done 3 squared times 3 to the 1st. You could have rewritten it, taken that extra step, and then said, okay, I've got the same base. I'm going to add the exponents. Now I'm right back to 3 to the 3rd. So either way would have been fine. All right, so on the next page, there's a checkpoint. So you're going to pause the video right now, and you're going to see if you can do these on your own. Okay, here are my solutions. You may have worked them out slightly different because there's a couple different ways you could think about them. Number one is just 8. Each one ends up being to the first power. You could have distributed the -1 power, then you would have to flip their position. It's just 8. This one, you're going to use your negative exponent definition, move it to the top. 3 times 3 is 9. All right, I use the quotient rule here, which is same base, subtract the exponent, so it becomes -1 from the top minus the power of 1 that's on the bottom, which is 6 to the -2. Then I rewrote it as 1 over 6 to the 2, using my rule of negative exponents, which is 1 over 36. And right here, it's 5. All right, it doesn't seem like I paused for long there, but I was paused for a long time, so I can't remember if I explained number 4 and finished it or not. So I multiplied my exponents here. It's 5 to the -2. Moved it to the bottom. 5 times 5 is 25. All right, so let's take a look at example 3. It's fun. And this is what we're doing now. We're mixing all of these different rules from 8.1 to 8.3 together. No rule is hard on its own, but when you put them all together, it starts to get confusing. So you're going to need to try to do your best to work through these problems slowly to keep the steps basically set in your mind. Okay, so looking at this right here, the first thing I see is that I have a negative exponent. And they're wanting us to use the definition of negative exponent. So I am going to rewrite this with that negative exponent on the bottom. So the power of this 2 is 1, and the power of that x is 1. That's something to remember. Also on bottom, there's an exponent of 1, an exponent of 1, and an exponent of 1, and all those. So the only negative exponent is the w on top. So I'm going to rewrite this as 2x on top. The w is going to get moved to the bottom, and it's going to be w to the third. And in parentheses, I still have 2wx raised to the second power. Some of you may have wanted to deal with this second power first. We could have done that, but I'm just going to kind of follow the steps that they have on the side there. All right, the next rule that we're going to use here is power of a product, because I need to deal with that big 2 out there. Power of a product. Okay, in order to do that, the 2x still is on top. The w to the third is on the outside. It's not raised to this power of 2. Then what happens is everything inside there gets raised to the power of 2. So 2 squared, I'm just going to write 2 squared is 4. W becomes w squared. X becomes x squared, because their exponent was originally 1, remember. All right, the next thing we're going to do is product of powers. Product of powers. Because I have some w's here that are the same base. And I don't even need those parentheses really there anymore. They're just kind of helping to keep things separated. But everything there on the bottom is getting multiplied. So the 2x is still rewritten. The 4 gets written first because it's a number, so it becomes the coefficient. W to the third and w to the second make w to the fifth. And x gets written just as x to the second. We also like to write our variables in alphabetical order, so that's why I wrote w first. Okay, the last thing I can see is that I have some coefficients here. I have a 2 on top and a 4 on bottom. And I also have an x to the first on top and an x squared on bottom. So I'm going to use the quotient of powers property. Okay? So first of all, you need to take numbers separate. So 2/4, just think of it that way. What does 2/4 reduce to? 2/4 reduces to 1/2, or 1 over 2. Now this is x to the first. There's 1x on top and there's 2 x's on bottom. So if I cancel them off, there's only 1x left down there. Also, you can think of it as 1 minus 2 is -1, so then it moves to the bottom and becomes x to the first. And then also w to the fifth, it just stays down there. So this is actually my answer in simplest form. 1 over 2 w to the fifth x to the first. Okay, so pause the video, see how you did on, see how you can do on 5 and 6. I'm going to flash the answers, and then I'm going to explain it after that. Okay, so here are the answers to 5 and 6. I hope that they're right. I'm going to work this out and we'll see if they're right or not. If you did not get those solutions, then you should be watching my explanation for these problems. If you got both of those, hopefully they're right, and you can move on to the next step. Okay, so let's see, what do I notice here? First thing I notice is 6 over 2. I'm just going to simplify 6 over 2, and I'm going to make a 3 on top. Okay? Now, another way you could think about these F's, if I write this off to the side here, there's one F on top, and there's 2 on bottom. So just by canceling out, there's only going to be 1 left on bottom. This is F to the first. The quotient rule tells us 1 minus 2 is F to the negative 1, so that F last on bottom there. Goes F to the first, back on the bottom. Now the G's are a little trickier. The G's become G, oops, that's a Q, G to the negative 4 minus 1 power, which is G to the negative 5th. So where does G to the negative 5th go? It goes on the bottom and becomes the power of 5. So that is my final answer there. All right, number 6. The first thing I need to deal with is this negative 2 out here. So I'm going to make that power of powers, go to each one there. So 3 to the negative 2, y to the negative 2, because remember these are to the first power, and z to the negative 4. So then I'm going to use my negative exponent rule, and I'm going to put them all on the bottom now and lose the negative sign. So 3 squared, y squared, z to the 4th. And then I'm going to simplify what I can. I have 1 over 3 squared is 9. Y squared just stays, and z to the 4th stays. So the book was right in their answers, and that's how you get it. All right, see Mrs. Lyman if you have any questions.